All right, we'll go ahead and get started. So make sure you've got VS Code pulled up, ready to go. It can be just right here. And we're going to go ahead and open two things. We're going to open the folder where we're going to keep our Python files. We may not actually make any files today, but we'd like to have that folder open. On Windows, you can click the File button and go down to Open Folder. And on mine, I've just got a folder named Python. So I'm just going to highlight that and click Open. And when you do that, you should see a list of files that are in that folder if you have any. All I've gotten here is the Python file from last time. If you can't remember what folder you used last time, it's okay, just make a new one. Remember that you don't want any spaces in any of the folder or file names. Once you've got the folder open, you'll want to open a terminal, and there should be a terminal button up in your menu bar. So you can just go down to New Terminal, and it will pop open a little window. Mine says it's a bash window. If you're on Windows, it'll probably say PowerShell. Is anybody having any trouble doing either of those two things? Not. So there's two ways to use Python. One way is with files, which we'll get into probably more next time, and that's going to be how we do our robot programming. But you can also use the interactive Python interpreter, and that's how we're going to kind of start playing around with some of these. The interpreter is nice because you get instant feedback on what you've typed and what you're doing. So it's a really good learning tool when you want to just try something out and see what it's doing. To launch the interactive interpreter, if you're on Windows, you're going to type py-3. If you type just py, it might work, but if you have Python 2 installed, it'll launch that. We want to use Python 3, so this will be py-3 and press enter. Now on mine, it doesn't do anything because I'm on a Mac. My command will look a little bit different. So I'm going to send the command for Windows. And then when I launch mine's just Python 3. No matter what you're running, you should see something similar to this output. It may not be exactly the same, but you should see some of the same information. For example, the version number is a good giveaway, and then some arrows indicating that we are in the interpreter now. To exit the interpreter, you just type exit with parentheses. To get back, you just type that same py-3 on Windows or Python 3 on a Mac. Any questions so far? Anybody hung up on anything? Okay, let's see what we've got next. All right, operations. So the nice thing with the interpreter is you can use it like a calculator. So if you want to know what is 3 plus 5, you get 8. If you want to know what is 5 minus 3, you get 2. If you want to know what 3 minus 5 is, you get negative 2. If you want to know what 7 times 6 is, you get 42. So right away, one nice thing with Python is that your addition, subtraction, multiplication works like you'd expect. And there's a few other operations. So we've got addition, subtraction, multiplication. The fourth major operation is division. So if I do something like 20 divided by 5, I get 4.0. If I do something like 20 divided by 4, I get 5.0. If I do something like 20 divided by 3, I get 6.6666666 repeating for a while. One thing to notice is that I didn't use any decimals in any of my numbers, but the division gave me a decimal. That's because addition, subtraction, multiplication, when you give it numbers without decimals, numbers that we call integers, it's going to give you an integer back. The division operation in Python 3 is a little bit different. It's going to give us a decimal number. We call decimal numbers float or floating point or floating numbers. So just so we have those, an int is no decimal, an integer I should say, and then floating point has a decimal. Addition, subtraction, and multiplication, if you give it integers, it'll give you integers, but floating point is division. Division is floating point, I should say. If you give it integers, it'll give you a floating point number. If you give it floating point numbers, it'll still give you a floating point number. So if I do 20.0 divided by 4, or 20 divided by 4.0, or 20.0 divided by 4.0, or 20 divided by 4, I get 5.0 for all those cases. So that's one weird thing that pops up with division, but there is a division that we can do that won't do that, and it's a special division. So there's another symbol. Let's see if clear will work here. No, okay, hang on, let me get back in. So we saw division, but there's also this thing called floor division. So here's an example of what I mean. If I do 1 divided by 2, I get 0.5. But if I do 1 floor division, 2 forward slashes, I get 0. This is kind of like when you do division and you get remainders. How many times does 2 go into 1? 0 times. How many times does 5 go into 10? 2 times. How many times does 10 go into 5? 0 times. So you won't get a decimal on these when we're using our integers, but you also won't get the remainder part. You'll just get how many times does this number go into this other number. So floor division is a good way to check divisibility in some cases, but not in most cases. So again, 5 divided by 6 is 0.83333, but 5 floor division 6 is 0. You should notice that when you do division and floor division, at least with positive numbers, the part before the decimal is going to be the same as the floor division. So even if I did that with something like 15 divided by 2, I get 7.5. So 15 floor division by 2 should give me 7. Negative numbers might behave similar. Let's see. 1 divided by 2 is negative 1/2. But if I do negative 1 floor division 2, I get negative 1. So it behaves a little differently with negative numbers. We can talk more about that later, but that's not critical to what we're talking about here. Just know that a floor division will take you to the nearest integer below or equal to you. So negative 0.5, the first integer below that is negative 1. 0.8333, the first integer below that is 0. We're going to stick to some positive numbers just for the time being until we get some better practice with it, but just know that when you throw in negative numbers, it does behave a little bit differently. And just out of curiosity, throwing in both negatives makes it behave a little bit differently still. Okay, so that's enough with floor division with the negative numbers. Let's remember to concentrate on our positive numbers. So let's see, we've done 4 times 5, or let's see, so 4 plus 5, 4 minus 5, 4 times 5, 4 divided by 5, 4 double division by 5 to give us floor division. The last division operation is the percent sign. It is modulus division. And in this case, all it's going to do is give us the remainder. 5 goes into 4 0 times with 4 left over. For floor division by 5, so 5 goes into 4 0 times with 4 left over. 4 goes into 5 1 time with 1 left over. So if we did something with 11, 3 goes into 11 3 times, but with 2 left over. So you can think of, when you're working with positive numbers at least, the floor division and the modulus operator together will do like when you did division problems back in elementary school and early junior high, where you would find the quotient and the remainder. Floor division will give us the quotient, modulus division will give us the remainder, and regular division will just give us a floating point number. So those are your 6 regular operations that you're familiar with, your 4 arithmetic operations. And those are all binary operations. And we say they are binary operations because they take 2 arguments or 2 parameters or 2 numbers. Notice every single one of those, there were 2 numbers that went into the calculation and it gave us a third number. There is also an operator called a unary operator, and it just takes 1 argument. So I could type the number 5 and get 5, or I could type -5 and get -5. In this case, the negative is a unary operator. It turns positive numbers into negative numbers, and it turns negative numbers into positive numbers. So that's something to be mindful of. Another unary operation we have is ABS. ABS is typed just lowercase abs, parentheses, and then a number inside it, and it will give you the absolute value of a number. ABS is an example of a function. It takes in a number, or it takes in some information and is giving some information back. I believe, okay, that's not one. So let me clear out. So if I do ABS on 9, it just gives me 9. If I do ABS on -4, it gives me 4. And there's one last operation, and that is exponentiation. I'm going to type that into the box here. Exponentiation. And it's raising a number to a power. So for example, 4, 2 asterisks 2. 4 raised to the second power is 16. 5 raised to the second power is 25. 6 raised to the second power is 36. 5 raised to the third power is 125. 2 raised to the 10th power is 1024. So this is like in math where you would have a number that's your base. So in this case, the first number is the base. The 2 was the base in the last one. And then after your operator, the next number is your exponent. In this case, 10 is the exponent. So 2 raised to the 10th power is 1024. So there are other math operations we can do, but those are the ones we'll just stick with for now. Are there any questions on any of these operations? These are all just kind of straight out of what you would have done in math before now. If you need to, we can look at some more examples of some of these. If not, the other thing to know is that, oh, go ahead. That is a good question. Let me look real quick for how Python does that. Oh, I believe, let's see. Nope. Okay. On Windows, it looks like we type in import OS clear equals lambda os dot system cls. And I'm going to copy those lines into the command for you. So that's the first line you type, and then the second line you type is that. Now on mine, I need to type clear in here. Then after you've typed those two lines in and press enter on both of them, then you can just say clear, it'll clear for you. Did that work? That's something you would have to do every time you started the interpreter. I've been just kind of closing my interpreter, then clearing, then opening it again. But that is a way to do it. Okay, so the other thing to know is that, like in math, we can get some complicated calculations. And for that reason, Python lets you use parentheses. So here's an operation. This one follows order of operations. So you multiply before you add. So 6 times 2 is 12. 12 plus 5 is 17. So it follows order operations there. 5 plus 6, 4. Exponents come before addition. So 6 gets raised to the 4th power before you add 5. So that's going to be, it looks like 1,296. And we add 5 to get 1301. And you can use parentheses. So if I type this expression, 5 plus 6 times 2 plus, I think that's the expression. It'll do parentheses first. So 5 plus 6 is 11. And then we do what's inside here. 5 times 2 is 10. 10 plus 2 is 12. So we get 11 times 12. So it should be 132. So we can use parentheses to break it up. But if we leave off of parenthesis, Python will give us 3 dots like it's still waiting on something. And until I give it the parentheses it wants. And in that case, I added too many parentheses, and it didn't like that. But there, I had it. So that's something just to be aware of, that it'll follow order of operations. You can use parentheses to break things up, but if you don't have the right number of parentheses, it will complain until you do. So one more, 4 times 4 plus 2. So I added 1, 2, 3 openings, so I need to have 1, 2, 3 closings, and I get the answer. Okay, so that about wraps up operations on numbers. We have our addition, subtraction, multiplication, which act like we expect. We have 3 kinds of division. We have regular division, which gives us a decimal. Floor division, which gives us just the quotient. Modulus division, which gives us just the remainder. Negation, which turns a positive number negative and a negative number positive. Exponentiation, which raises the first number to the power of the second number. And ABS, which takes the absolute value of the number. any questions on basically using Python like a calculator? So there's a couple more things we can do with them. The first is if we get a number and want to know what type it is. Python has a function called type. So 5 is an integer, so it tells me that it's an int. But 5.0 is a floating point number, so it tells me it's a float. So if you're ever curious what a number is, and this will become more important if you start using variables, which we'll get to later, then this will tell you what you're looking at. What's more, sometimes we will actually mix and match integers and floating point numbers. So it's important to be able to work with that. So if I do 4 plus 5.0, I'm going to get 9.0, even though 4 is an int. So it'll change ints to floats, but not floats to ints in this case. So if we want both of these to be ints, I can actually say, okay, just make that an int. And now it'll give me an int back. I could have also done it this way and still gotten 9. I can also, if I want floats, say floats. So that's something that we call type casting, where we're saying, hey, I wrote this as an int, but I want you to treat it like a float. Or I wrote this like a float, but I want you to treat this like an int. Or whatever you get at the end of this operation, I want an int. Or whatever you get at the end of this operation, I want a float. So I can say float 4 plus 5 and get 9.0. But if I don't have the float there, it just gives me 9. So that's typecasting, and it's important to be able to use correctly. But when you do use it, make sure you know that you are using it, and make sure you know why you're using it. Otherwise, you might get some weird calculations that you aren't expecting. So those are two of the types we have, integers and floating point numbers. Any questions on types of numbers? So the next thing we can do with numbers is compare them. So let's say we have the number 3 and the number 3. If we want to check if the number of 3 is equal to the number of 3, we use 2 equals signs. And it tells me true. If I want to see that they are not equal, I use an exclamation point with an equals sign. And it gives me false. So true and false are these Boolean values for Python. Notice that they're capitalized, just their first letter. So the equality operation is double equals. The not equal operation is exclamation point equals. And we can also check things like less than. So if I say, is 3 less than 4? That's true. Is 4 less than 3? That's false. I can also say, is 3 greater than 5? Or is 5 greater than 4? True. So our less than, greater than signs are 2 more comparison operators. And then finally we have, okay, so 5, is 5 greater than 5? No, that's false. But is 5 greater than or equal to 5? That's true. Is 5 less than 5? That's false. Is 5 less than or equal to 5? That's true. So we have less than or equal and greater than or equal. So that's how we compare two numbers or two things, and it'll either give us back true or false. The only time it wouldn't give us true or false back is if there were some kind of error. So you'll always get true or false with these. One way that you can get into trouble, 5 is equal to 5. 1 is equal to 1. 1 is equal to 1.0. 1 is equal to 0.1 times 10. True. 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 Let's see. Still true there. So there's that. So generally, we don't like to compare floating point numbers. This implementation of Python seems to be handling it okay, but generally we don't like to use the equal operator with floating point numbers. So keep that in mind. Equal and not equal should generally, with numbers, be limited to integers. So it's okay to say, is 1 equal to 2, or is 1 equal to 1? But we wouldn't want to say 1.0 is equal to 1.0, just because that may not always be correct, because computers have a hard time storing some decimal numbers. But in Python, this problem seems to be at least a little better handled. But just remember, equal, equal, and not equal, try to limit those to integers. So far that takes us through three kinds of data: integer, floating point numbers, and Booleans. Any questions on those three before we cover the fourth major kind? And that should be the last kind we talk about today. So the last data type we're going to talk about today is a string data type. And strings are ways of storing text. Strings are a little bit different than these other guys. Strings are objects, so they act a little bit differently. In Python, there's a few ways to write strings. You can use single quotes, and it stores all that. You can use the double quotes, or you can use triple quotes, 3 single quotes. Oops, if I could spell. And it likes that. But if you mix and match your quotes, it's going to complain until you get it. I noticed it gave us some weird symbols there. We'll talk about what those are in just a minute. But you can use, like I said, single quotes, double quotes, 1, 2, 3, 4, 5, 6, or triple quotes. Notice that all of these, there's nothing in them. We call those the empty string. So strings have methods because they are objects. So for example, ABS was a function. It was by itself, and you could plug something into it. Strings and numbers also have operations, like 5 plus 3 gives me 8. Strings can have some of these things. We'll talk about what some of them are. But strings also have methods. So a way a method looks is dot. Let's see, what's a good one? Up it. So you type the full string, you add a dot, and then the name of a function. And that's what we call a method. So it's going to take that string and make it uppercase. We've also got a method called lower, which will make all of our string lowercase. We've got one called capitalize, which will capitalize that first letter. And let's see what it does if I've got 2 words in here. It just capitalizes the first one. But there's also a method called title, which will capitalize each letter of each first letter of each word. We've also got a method called isAlpha. And isAlpha basically says, does this string only have letters? So if you give it anything other than a letter, just a single one, it'll give you false. But if it's only letters, it'll give you true, even if it's a mix and match of capital and lowercase. I believe there's an isLower method. Yep, and it'll give you if every letter is lowercase. There's also an isUpper method, and that'll give you if every letter is uppercase. But it'll be false if even a single letter is not uppercase. So those are just some of the methods of strings. There are other methods. I'm going to include a link to the documentation that you can kind of just go through at your leisure and just kind of read about it. There's just a lot of information there about strings, and a lot of it you're not going to understand at this point. A lot of it is kind of advanced for what you can do with strings, but there are some things about strings in there, but we won't get too deep into those right now. Any questions on these methods with strings? There's a few more things we can do with strings, but these are just some of the methods that we're going to need to just be aware of first. Okay. In addition to methods, we do have some string operations. Oops. So I can type this string and I can type this string and it adds them together. So addition does kind of work with strings, but we don't call it addition. We call it concatenation. Concatenation. It's just combining one or more strings together. You can also multiply strings, but not specifically. So I can say hello times 5. That gives me hello 5 times in a row. Wonder if the order matters here. That'll work too. But notice if I try something like this, I get an error. One of them has to be not an integer. But those are two of our operations with strings, and those are both concatenation. We can also compare strings. A comes before B. Oops. A comes before B. A comes after B. C comes after B. Little c comes after B. A comes before AA. So unlike numbers, we're not comparing if these are bigger than each other. We're comparing if they come before or come after each other in a dictionary. So if I had something like, does banana come before orange in the dictionary? It does. Does banana come before orange, or is it the same word as orange? That's true. Does orange come before the word orange? It doesn't. Does orange come before the word orange, or is it the same as the word orange? It is. Is the word orange the same as the word orange? It is. Is the word orange not the same as the word orange? It's not. So you might hear this phrase sometimes as lexicographic ordering. In this case, we just mean where do they compare to each other in the dictionary. There's a couple more things we can do with strings. For example, if I have world with a bunch of blank space after, we call that white space. I can use the strip method. It takes off the white space. That works if there's white space before or after. But it won't affect white space in the middle. We've also got lstrip, which strips only the white space on the left. And we've got rstrip that only strips the white space on the right. But notice that none of these methods affects the white space in the middle. So if you have white space after any symbol, but before any other symbol, it won't get rid of that. Just the white space on the ends. And again, you can limit that by left or right, depending on which side you want to get rid of or keep. Any questions on these string operations or these string comparisons? Okay, so the last thing that we'll talk about with strings are some special characters. So I can type in hello world just like that, but if I want them on two different lines, I can add a \n. \n means insert a new line. Now I'm not seeing that here, but if I go into my print method and type hello \n world, I get it there. So just typing it into a string may not make it behave the way you want it to, but you can see that there. We've also got a \t that adds a tab, and you can compare these two to see the difference. There's hello world, and there's hello world on the line above it that has a tab inserted. One thing that you might want to do is put some quotes inside it. So for example, I could say, he said, my name is, and stopped talking. Now notice that's okay because I mixed and matched my strings. I used single quotes on the outside and double quotes on the inside. But if I wanted to use single quotes for both of them, I'm going to get an error. I can fix that by saying, okay, I really want single quotes here, so let me put a \, before these single quotes. And now the line's fine with it. Likewise, we can do the same with our double quotes. So if I have double quotes everywhere instead of single quotes, I would have the same error. But this is okay. So just know that the \, is Python's way of saying, hey, there's going to be a special character here. The big times we use that are for line breaks, tabs, and quotes. But sometimes you need to say what a \, is. I get an error because \quote actually means something. To type in a \, I need to say \\. Now here, it looks weird because we see two of them. But if I call the print on this, then it only prints the one. Now there are some other special characters, but for now, those are the only ones that we're going to look at. Just know that they exist, and if we need them, we will use them. Any questions so far before we look at the last bit of information? Not. If not, then the last thing we're going to talk about is variables. Variables in Python are very nice and simple. To declare a variable, you just give it a name equals a number or equals another number. And now Python knows what A and B are, so you can do operations on them. So you can say, what is A plus B? You get 11. What is A times B? It's 30. A minus B, -1. A divided by B, A divided by 5. A divided by B. A floor B. A modulus B. A exponent B. You can mix and match with numbers like we saw. A plus 4 would give me 9. I can store the results. I can say C equals A times B. Well, I can say, well, what's C? I can say print C, or I can just type C. Both times give me 30. And we're going to talk more about the print statement maybe next time because there's a lot you can do with it. I can do A, comma B, comma C, and it'll give me those numbers so I can check them whenever I want. You can also store strings. So I can say word is world. I can say A times my word and get a concatenated string that way. I can say that my favorite fruit is banana. I can say that my loud fruit is fruit dot upper. Well, what's loud fruit? And store it that way. So the variables are all used the same way. It's always name equal and then a number or a string or some operation on numbers or some operation on numbers and letters. The only rules with names are that you have to use letters. You can also use numbers, but it has to start with a letter, or use underscores. So name1 is an okay name. Name1 is an okay name. Name1 is an okay name. But one name is not an okay name. But underscore one name is an okay name. So these are variables, and they're just used to store information. We're introducing these kind of fast here, but we will be spending more time with them next time. And I hope next time we spend a little bit less time in the interpreter. But the interpreter is a good place to practice. So I would play around with it. And let me see. One more thing that we might worry about is with division. Is division by 0. The good news is Python has an error for that. Are there any questions? If not, then we'll wrap up. But I'm going to type in a problem, and this is something that you can kind of work on and play around with in Python between now and next time. I'm going to read it as I type it. You're going to order some supplies from the store, and you want to know what the total price is. So this is going to be kind of like using Python as a calculator, but see if you can do it with just one line of Python. And you want to figure out what the total price is. So the supplies cost $10. Your discount is 30%. State tax is 5%. And shipping is $7.50. So again, cost is $10. Your discount is 30%. State tax is 5%. And shipping is $7.50. So this is it is a simple problem that is multi-parted. You should be able to write this in one line of Python. It will take some practice to get to that point, but it is a good way to kind of see a lot of things we've been doing. So what I would recommend is practice this a little bit. I hope to start next time by looking at a solution to this, but try to work this out on paper first and see if you can get the answer that way, and then try to write the Python code for it. This is something we can talk about next time, but like I said, this isn't really to say if you can or can't do this, then you're good or not good. This is just something you can play around with and try out between now and the next meeting. But use this to try to find what the total price would end up being. Just remember that the discount would not apply to shipping. It only applies to cost. Any other questions? All right. Then remember to exit out your terminal. It's exit with those, and then if you're on Windows again, to relaunch it, it's py-3. If you're on Mac or Linux, it's probably Python 3. But that being the case, I will wrap this up, and I will see everybody next week.